I'll solve few more problems on Laplace transforms. So I'll consider the problem. Consider L of sine AT by T. It's a very simple problem. Uh, uh, this one will be what we are going to study. So solution. This is my sixth problem, I believe. So solution. What I should do? I should consider L of sine AT. What that will be? It is A over S squared plus A squared, right? So therefore, what is L of sine AT by T? So that will be equal to what? Integration from S to infinity. It is A over S squared plus A squared ds. Right. So what is A over S squared plus A squared ds? So this will be equal to A times integration from S to infinity ds over S squared plus A squared is what? 1 by A tan inverse S by A from S to infinity. So this A cancels. So this will be what? It is tan inverse S by A from S to infinity. So this will be what? If I put S is equal to infinity, I get tan inverse infinity minus tan inverse S by A. Right. So tan inverse infinity is pi by 2. So this is pi by 2 minus tan inverse S by A as tan inverse tan pi by 2 is infinity. Tan pi by 2 is infinity. Therefore, this one we write as tan inverse infinity pi by 2. Similarly, you can even write the minus of tan inverse s by a as cot inverse s by a. That also is, you can write that also. Cot inverse. Pi by 2 minus tan inverse s by a is cot inverse s by a. In some words, you might get this as cot inverse s by a. So this is the result. Therefore, sine AT by L of sine AT by T is what? Either pi by 2 tan inverse S by A or cot inverse S by A. Both are okay. So this is how we we come across such problems. Hmm. Similarly, sin AT into cos BT by T. And here we come across in Laplace transforms of whatever you have studied so far, we come across the problems like this. Using Laplace transforms, using Laplace transforms, evaluate the following integrals. Evaluate the following integrals. So the first problem I am going to consider will be mm, integration from 0 to infinity. The first one, integration from 0 to infinity, it is uh, e raised to sin mt, sin mt by t dt. I consider a simple case, right? So this will be equal to, what I will do here is, see, you look at this problem. You consider, say I consider this one now. Consider solution. Consider L of sin mt by t. Right. So what is L of sin mt by t? Why I am doing all these things is, see, what is L of sin mt by t by definition? sine mt by t will be what? It is integration from 0 to infinity e power minus st, right? E power minus st into sine mt by t dt, right? So for s is equal to 0, what happens? The above integral can be written as above integral can be written as uh, 0 to infinity e power 0 t is 1, so sine mt by t dt, right? Therefore, integration from 0 to infinity sine mt by t dt will be what? It will be L of sine mt by t at s is equal to 0, or for, instead of at, write for s is equal to 0. Now, so I should find out L of sine of mt by t, put s is equal to 0 in that to get the required result. So what is L of sine t? Therefore, now consider L of sine m times t. So what is that? Sine of m times t is over s squared plus m square. This we have already studied. Instead of sine at, it is sine mt, right? Therefore, L of sine mt by t will be equal to what? Integration from s to infinity m over s squared plus m squared dx, right? So this already we have evaluated. For what this will be? This will be equal to what? Tan inverse s by m from s to infinity, or this, because we have studied, we have solved this problem. Tan inverse infinity is pi by 2 minus tan inverse s by m, right? So in this I should put tan inverse 0 now, right? So what is tan inverse 0? So this is the answer, tan inverse. Therefore, L of sine mt t will be what? It is pi by 2 minus tan inverse s by m. Therefore, integration from 0 to infinity L of this one, sine mt by t dt will be what? It is, this we have already evaluated, sine mt by t s is equal to 0, right? What that will be? If I put s is equal to 0, it is 0 because s 0 by m is 0, tan 0 is 0 because tan inverse 0 is 0 because tan 0 is 0. Therefore, this will be equal to what? Pi by 2. So therefore, L of, 0 to infinity, sine mt by t dt will be what? Pi by 2. So this is how you can, using Laplace transform, you can evaluate certain indefinite integrals. So this is one of the problems I have solved in this one. Similarly, you can solve few more problems. What it says is the second one, the second problem, using Laplace transforms, evaluate the following integral. So the second result will be, using Laplace transforms, 0 to infinity, you have to find out 0 to infinity e power minus 2t into sine squared t dt, sine squared t dt. Right. Now what I should do? I have to find out, see, this will be what? See, if I consider L of sine squared t, right? By what is the definition of this? It is 0 to infinity e power minus st, right, into sine squared t dt. Correct? No. So if you compare these two, what is the s value here? So it is 2 here. Therefore, integration from 0 to infinity e power minus 2t sine squared t dt will be what? It is L of sine squared t for s is equal to 2. Now you compare these two integrals. See here minus s, if I replace by 2 I get this integral. Therefore for s is equal to 2. So now what is L of sine squared t? L of sine squared t will be equal to L of 1 minus cos 2t by 2. Right. So this will be equal to half. Right. So 1 minus cos 2t by 2 is 1 by s. L of cos 2t is what? S over s squared plus 4. Right. So therefore, what is the L of this is equal to, if I simplify this, half of, right, if I take LCM, s squared plus 4 minus s squared divided by s times s squared 4. If I simplify this further. So this plus s squared minus s squared cancels. So 1 by 2 times 4 times s over s squared plus 4 will be what? It is 2 over s times s squared plus 4. So, right. So this is L of sine squared t. Therefore, integration from 0 to infinity e power minus 2t squared t dt will be what? It is, right, 2 over s times s squared plus 4 for s is equal to 2 because it is L of sine square t at s is equal to 2. So what is the answer? So this will be equal to 2 over 2 times 2 squared plus 4 1 by 8. Therefore, integration from 0 to infinity e power minus 2t sine squared t dt will be equal to what? 1 by 8. So this is how I can evaluate the definite integrals using Laplace and transforms. One more example I consider. Prove that the third problem I consider. Prove that prove that 0 to infinity 0 to infinity, right? E raised to minus t sine squared t by t dt is equal to 1 by 4 log of 5. 1 by 4 log of 5. So now what I should do? If you compare this, if I consider L of sine square t by t, now proof L of sine squared t by t will be what? It is integration from 0 to infinity e power minus st into sine squared t by t dt. Correct? E squared e power minus st into sine squared t by t. Comparing given integral and RHS of above equation, above integral, we find that S is equal to what? Because e raised to st is there, therefore S is equal to what? It is 1. Right? Therefore, integration from 0 to infinity e power minus t sine squared t by t dt will be equal to what? It is L of sine squared t by t at is equal to 1. For s is equal to 1. So my aim is what? I should find out L of sin square t by t, then put s is equal to 1. So therefore, what I will do, consider sin squared t by t. Right. I have to find out this one now. Now, L of sin squared t is equal to what? L of 1 minus cos 2t by 2. Right. For this one already we have studied. So this is equal to what? Half of L of 1 minus cos 2t. So this will be equal to what? Half of L of 1 is 1 by s minus L of cos 2t is s over s squared plus 4. This we have already evaluated, I believe. And square t by t we have already evaluated. Therefore, L of by t will be what? Integration from s to infinity. It is half of s minus s over s squared plus 4 dx. Right. So 1 by 2 is right. So I have solved, since I have solved this problem, right, integral. So log s 1 by s ds over s is log s. Then ds over s squared plus 4 is what? It is log of square root of s squared plus 4. So if I simplify this, so this will be 1 by 2 log of s over under root s squared plus 4 from s to infinity. Right. So this will be equal to what? 1 by 2 log of s over under root s squared plus 4. So it is log of this already we have evaluated 1 by 2 times log of under root s squared plus 4 divided by s. Huh? This already we have evaluated. Therefore, since we have used this formula already, therefore it is 1 by 2 times this. Therefore, that L of sin squared t by t will be equal to what? Equal to 2 log of s squared plus 4 divided by s. Therefore, integration from infinity e power minus t sin squared t by t dt will be equal to what? It is L of ft by t at s is equal to 1 or s is equal to 1. That is 1 by 2 times. I have wherever s is there, I replace that by log of root of 5 divided by 1 root of 5. So this is equal to 1 by 2 log of 5 raised to half. Log of a raised to, so this will be equal to what? 1 by 2 into 1 by 2 times log of 5. Because log of a raised to m is m times log of a. This will be equal to 1 by 4 log of 5, which is equal to RHS. So therefore, LHS is equal to 0 to infinity is equal to RHS. So like that, see, using Laplace transforms, we can evaluate certain results. This we can you can take a few more problems for practice in the Google Classroom, and you just solve those problems, and you take it as an assignment. So solve those problems, right? So with this, stopped here now. In the class, I'll start with Laplace transform of uh, Laplace transform of derivative.